Hello and welcome. Today's class is going to be on cold chain route of vaccination and injection technique. So this class will be especially helpful and useful for nursing, medical and paramedical students. All of us know vaccination saves millions of lives every year, but this is possible only when vaccines are stored correctly. It is given by correct route and administered using proper technique. So today you will learn how cold chain is maintained, what is cold chain, and then you learn the correct route of giving different vaccinations and the proper injection techniques. So we'll start with the cold chain followed by route of administration and then the correct techniques I'm going to talk on. Let's start with cold chain. This is a system of storage and transport of vaccines at recommended temperature from manufacturer to actual vaccination site so that their potency and efficacy are preserved. So failure in the cold chain may lead to vaccination failure. So this is very important. Okay, why cold chain is important? The answer is all vaccines, they tend to lose potency on exposure to heat above plus 8 degrees Celsius. And some vaccines are there that lose potency when exposed to freezing temperatures. So due to the inappropriate temperature that is damaging the vaccines are irreversible. The cold chain is standard practice for vaccines throughout the pharmaceutical industry to maintain its efficacy. There are three vital elements in successful cold chain. Number one, cold chain equipment. Examples: walk-in cold rooms, walk-in freezer, ice-lined refrigerators. Number two, transportation, where cold boxes, vaccine carriers, ice packs are used. And number three, motivated and trained manpower, cold chain officers, cold chain assistants and other health service providers. So regarding all this, I'll be talking in detail because all these are very important part or important steps for maintaining the cold chain. So these three vital elements are going to maintain the cold chain. That means the efficacy of the vaccine. The cold chain equipments are the tools and devices used to store and transport vaccines at correct temperature, that is plus 2 to plus 8 degrees Celsius, from manufacturer to point of use to keep vaccines effective. So the equipments used are: number one, ice-lined refrigerators, deep freezers, walk-in cold room, walk-in freezer. Number 5, cold boxes. Number 6, vaccine carriers. And number 7, ice packs. So these 5, 6, 7 are usually used during the transport. So in detail I'll discuss regarding all these points. Next, cold chain equipments are thermometers, freeze indicators. Number 10, 30-day temperature recorder, that is also known as 30 DTR, vaccine vial monitor and domestic refrigerator. Let's start with number 1, that is ice-lined refrigerator. These are specialized cold storage unit which is used to store vaccines at the health facilities using an internal ice lining. It maintains the temperature at plus 2 to plus 8 degrees Celsius even during the power cuts. So most commonly it is used for routine immunization. So in the picture you can see it looks like this, the ice-lined refrigerator. And this is specially used in areas with the unreliable electricity because even during the power cuts it is functioning. And often there is a top opening like this, like you see in this picture. There is a top opening lids that is to minimize the cold air loss. Then it can run on solar power also, making them vital for public health in remote settings. So where the electricity is not there or there is a problem of electricity, especially in developing countries, this is very helpful. Number 2, deep freezer. it looks like this. It is used to freeze ice pack also, stores vaccines that tolerates freezing like OPV vaccines, and temperature range is from -15 to -25 degrees Celsius in this deep freezer. Then comes walk-in cold room and walk-in freezer. These are crucial component of cold chain, serving as large-scale stationary storage for temperature-sensitive vaccines. Essentially, it is customizable insulated rooms designed to maintain specific low temperature ranges consistently. So the room looks like this. Walk-in cold room. It is a large cold storage facility at national or regional vaccine stores, and this maintains temperature at +2 to +8 degrees Celsius. Next was walk-in freezer. So walk-in freezer is another large freezer for bulk storage of vaccines and then ice pack preparations. It maintains temperature at -20 degrees Celsius or even below. So this you can see, this is a walk-in cold room with the walk-in freezers. Next equipment is cold box. So like you see in the picture, this is a cold box. This is an insulated box for transporting large quantities of vaccines to the outreach clinics or outreach sites. It keeps the vaccine cold for several days, that is at least 1 week. Without power, it can keep the vaccine cold by using the ice packs also. So this is a cold box. Next, vaccine carrier. So vaccine carrier looks like this. It is a smaller insulated container used by the health workers, and they carry this vaccine carrier in the vehicles, bicycle, or even by foot. By walking, they can carry this to the outreach sites or the mobile stations, mobile clinics, and then this keeps the vaccine cold for 12 to 24 hours. Many places they use flask, so flask as substitute for vaccine carrier should not be done, so that should not be used. Flask should be avoided, but many places they even use flask. So here the vaccine is going on. This is a vaccine carrier, usually carried by the health workers. Next equipment was ice pack. So ice pack, it looks like this. So this is a filled with water, the containers filled with water, and then it is frozen in deep freezer. It is placed inside the cold boxes and then vaccine carriers to maintain the temperature. Next was the temperature monitoring devices. So those are thermometers. So different types of thermometers are available. So it measures the refrigerator temperature. Different types can be STEM, digital, minimum maximum thermometers. There are other known as freeze indicators. This detects accidental freezing of vaccines. And then next was 30-day temperature recorder known as 30 DTR. This continuously records the temperature for monitoring the cold chain performance. So throughout month they are monitoring. Next come to vaccine vial monitor, which is important to check for the potency of the vaccine. So vaccine vial monitor is a thermochromic level which is seen on the vaccine vials, which gives a visual indication of whether this vaccine is maintaining the temperature or not. If the temperature is not maintained, then this color will change. So this indicates the potency of the vaccine. So there is a circle with a square. So this square is a thermochromic level which indicates the potency of the vaccine. Vaccine vial monitor was introduced in 1996 and in labels designed mainly for the developing countries where the cold chain is difficult to preserve. So this one has a round circle, inside is a square. So square is lighter, white colored, and then blue color circle. So until the This white color is maintaining the color. There is a potency of the vaccine. Once this becomes same color as the circle, or it becomes darker like this right side picture, this has become black, then this vaccine should be discarded, should not be used. So you can see it consists of a heat sensitive square, this white one, with a circle. And on exposure to the heat, this color changes, the color of the square gradually changes, and then it becomes similar color or darker than the circle. So in this picture you can see this has become dark or black. So this means this vaccine vial is damaged. So this vial should be discarded, should not be used. But until the square is remaining lighter, then this can be used. So again, just see, there are 4 pictures, 1, 2, 3, 4. 1 and 2 can be used because the central square is lighter than the circle outside. And this one is still lighter than the circle outside. Number 3 and 4 picture, this cannot be used because in this the circle and the square is of same color, number 3 picture. And number 4 color, the central square has become darker than the circle. So this should be discarded. This is very important, that is why I am showing you repeatedly, because once this color is changed, you have to discard the vaccine, otherwise there is a vaccine failure. So vaccine vial monitor, in the freeze-dried vaccines like BCG, measles and all, the vaccine vial monitor is in the top of the cover. And in case of the liquid adsorbed vaccines, the vaccine vial monitor is in the body, like you see over here. Here in the body you are seeing this is a freeze-dried vaccine in the top. Okay, so in the cover, top of the vaccine, you will see the monitor. Next was domestic refrigerator. Actually, domestic refrigerator is not recommended for storage of vaccines, but in many countries, especially developing countries or many places where those other facilities are not available, they have to use the domestic refrigerator. So if you use the domestic refrigerator, you have to keep in mind different points, like don't store food, drink or clinical specimens in the refrigerator where you are storing the vaccines. And the opening of the refrigerator door should be kept very minimum. Don't open it wide like this, the way you see in the picture, so that the temperature is maintained. You will not lose the temperature. So try to open the door at a minimum. The correct placement of vaccines and the ice packs in a domestic refrigerator is shown in this picture. So just see carefully. In the freezing compartment, above is a freezing compartment. So here, topmost part, you will put the ice cubes. Then after that comes the place for oral polio vaccines. Below that is the main compartment containing top, middle and then lower part. So in the main compartment, topmost part you'll put BCG and measles vaccine. In the middle compartment, that is for the pentavalent vaccines, DPT, DT, TT, all pentavalent vaccines, typhoid vaccines and hepatitis A vaccine, hepatitis B vaccine and varicella vaccine. And the lowermost compartment, you put the diluents. So just remember, topmost BCG measles, lowermost diluent and all the other vaccines should be kept in the middle compartment. And in the side door, nothing should be kept in these areas. So if you maintain this, you can still use the domestic refrigerator to maintain the cold chain. So the parts of domestic refrigerator I have already explained. The freezer compartment contains ice cubes, then OPV ampoules. The temperature is -20 degrees Celsius and the vaccine life here is 3 months to 1 year. Then the main compartment, there are 3 parts. So topmost part are containing the freeze-dried vaccines like BCG, measles, even MR and MMR are kept over there. Middle compartment, DPT, TT, TT, pentavalent vaccine, typhoid, hepatitis A, hepatitis B and varicella vaccines, and the lowermost compartment there is diluents. The power support equipments supporting the cold chains are voltage stabilizer, generators, solar powered refrigerators, and used in the areas without any electricity or where the electricity cutoff is very frequent. This is a cold chain system diagram, so where they show the vaccine starting from the manufacturer point till the point of use, how they are stored and transported. So after the manufacturing of the vaccines, it goes to the bulk storage, that is at the National Vaccine Store. So they are kept in walk-in cold room, walk-in freezer. After that, it goes to the distribution storage, that is the regional or state store, kept in the cold room or deep freezer. Then comes the intermediate storage, that is the district store, where it is kept in the ice-lined refrigerator or deep freezer. And then it goes to the daily vaccine storage, that is in the health facilities, where they are kept in the ice-lined refrigerator. If not available, then even the domestic refrigerator with the proper precautions. And then comes the temporary storage, where it goes to the outreach session or the mobile clinics. So here the vaccine is carried in the vaccine carrier with the ice packs, or even the vaccine boxes are used. Then finally it goes to the child or the beneficiary. Now come to route of vaccination. So different routes of vaccinations via which vaccine can be given is oral route. Here you can see in the picture the oral vaccine being given. Examples are OPV, oral polio vaccines, rotavirus vaccine, and the intradermal vaccines, BCG vaccine, intramuscular route, and then subcutaneous routes are used. So the route of administration, oral vaccines are oral polio vaccines, rotavirus, intradermal is BCG, rabies, subcutaneous, measles, mumps, rubella, MMR, IPV, injectable polio vaccine, pneumococcal vaccine, influenza vaccine. And then intramuscular vaccines are pentavalent vaccine, DPT, DT, tetanus, that is TT, hepatitis A, hepatitis B, pneumococcal vaccine, rabies, Haemophilus influenza B vaccine, influenza vaccine, and varicella vaccines. Now come to the suitable site, that is the injection technique. The site should be chosen so that the injection avoids the major nerves and blood vessels. So correct site should be selected. So when you give a BCG vaccine technique, that is the intradermal route. So here you can see in the picture, it is showing how correctly you should be approaching through the intradermal route. So in this, skin should be stretched between thumb and forefinger, like you see in the picture. The thumb and the forefinger is stretching the skin. Then the needle is inserted with the bevel end upwards. Look at this bevel end. It is facing upwards. Facing upwards for 2 mm into the superficial layer of the dermis. This way you have to insert, and the syringe or needle should be almost parallel with the surface, making an angle of 15 degrees. So this angle should be just 15 degrees. And then when you insert, the needle should be visible beneath the surface of the skin. After inserting, just check the bevel end should be up, and then the needle should be visible at the surface of the skin. So this is the way you select the intradermal route. And below is the all subcutaneous tissue and muscle. So it is very superficially you should be entering. So this is the technique for intradermal route or the BCG vaccination. The suitable site for BCG vaccination is at the insertion of the deltoid muscle in the right or the left arm. Many countries it is given in the left, and some countries it's given in the right side. The shoulder of the tip of the shoulder is avoided because there is a risk of keloid formation at that area. So BCG suitable site is selected at the insertion of the deltoid muscle. Now let's see the injection technique of BCG. So when you give the vaccine, a considerable resistance should be felt and a raised blanched bleb showing the tip of the hair follicle should be seen. If you see that, that is the sign that injection has been correctly administered. And a bleb of around 5 to 6 millimeter in diameter is seen, which is approximately 0.05 ml, and this is a useful indication of volume that has been injected. If you don't feel the resistance, then you have to remove the needle and reinsert again before you give more of the vaccine, because the technique is not correct if you don't feel that resistance. So feeling the resistance and there is a blanch showing the tips of the hair follicles is an indicator that you are giving the vaccination in a correct technique. Now the suitable site for intramuscular vaccination. For infants less than 1 year, anterior lateral aspect of the thigh, just see in the picture here, the anterior lateral aspect of the thigh is selected for the intramuscular injection. And this area provides a large muscle mass into which vaccine can be safely injected. So when you give intramuscular injection, that is given with needle at a 90-degree angle to the skin, the way you see in the picture. So 90 degree you go deep. Skin should be stretched, not bunched, but it should be stretched. And then the needle should be at 90-degree angle like this. Then you go deep to the muscle layer. Skin, there is a subcutaneous tissue, and deep is the muscle. So this way you should be giving the intramuscular injection. Now come to subcutaneous injection. When you're giving a subcutaneous injection, it is given with the needle at an angle of 45 degree to the skin, and skin should be bunched, not stretched. When you give vaccines, it is not necessary to aspirate the syringe after needle is introduced. Again, similarly, this is intramuscular injection in the muscle layer, and this is subcutaneous at the subcutaneous layer. So here there is a 90-degree angle with the skin, and this is 45-degree angle with the skin, that is the subcutaneous. Site of administration of different vaccines. So intradermal, over insertion of left or right deltoid muscle. Subcutaneous, anterolateral aspect of thigh or upper arm. Intramuscular, anterolateral aspect of thigh in infants, and deltoid muscle in the older children or adults. Choice of needle. For intramuscular and subcutaneous injections or the vaccines, needle should be long enough so that vaccine is injected into the muscle or deep subcutaneous layer. So that is 25 millimeter needle is suitable for all age group in case of children, and for the adults 38 mm needle is required. And the width of the needle, that is gauze, is also considered. So in the infants 23 gauge, that is blue, 25 gauge, that is a orange needle is used, and older children and adults 23 gauge needles are used. Wider bore allows vaccine to disperse over large area, reducing the risk of localized redness and swelling. And for the intradermal administration of the vaccines, use 26 gauge 10 mm needle. Okay, thank you. Hope this class was useful for you all, and hope you all can give the vaccination now. Next class, I'll discuss or I'll give some tips on the vaccinations, then followed by the routine vaccination and optional vaccination. So maybe I'll take 3 more classes on immunization. Thank you.